In this task, I'll take the multiband image we worked with in Task 1 and perform a supervised classification of it. In a supervised classification, you choose the areas that will be used as training areas for the analysis. The training areas should be homogeneous samples of a particular feature, such as the forested areas. For each training area, the multispectral pixel values are extracted and used to define a statistical signature. This signature is a statistical representation of a particular class, such as the forested class, which is used by the software to identify all pixels with a similar signature. For this task, we'll be moving out of QGIS Desktop and we'll be using Multispec, shown here with the image loaded. Multispec has two windows, the image view and a text output window, and I've arranged this so that both windows are visible. So I'll start by going to the File menu and choosing New Project. I'll take the defaults in the Set Project Options window and click OK. And we get a small project window that also opens. I'll begin the analysis by selecting my training areas. And again, these will be areas that are homogeneous, and I'll start with this forested area. I'll just drag a box within that area. And one note, you should be careful not to define your training areas near edges of the field or a forest. You should stay away from edges by a couple of pixels to reduce the chance of edge effects. If upon inspection you don't like the exact area chosen, you can immediately repeat the process. So now that I've delineated this area, I'll choose Add to List, and I'll give the class a name. I'll call it Trees, and click OK. I'll define 5 additional training areas: wheat, soil, light soil, no data, and weeds. Now I've done delineating my 6 training areas. As you can see on the map, it shows you the rectangle and the name of each class. And I'll click this Classes button in the project window to see the classes listed here. And if necessary, you can delete a class by selecting it in the list and going up to the Edit menu and choosing Cut Class, and then just regenerating it. Now from the menu bar, I'll choose Processor, Classify, and I'll uncheck Image Selection. The other default settings are fine, and I'll click OK. And I'll click OK when I get this Update Project Statistics before continuing question. Since I unchecked image selection in that Set Classification Specifications window, Multispec only estimated the quality of the training areas here, and I can examine the tabular output. So I'm going to move my project window and expand my text output window so I can see the whole thing. And here I'm going to look at the training class performance, and specifically the reference accuracy. This percentage should be near 100% for all the classes. Since these are all good results, I know I'm ready to run my analysis. So I'll go ahead and minimize this back over to the side so we can see the image. I'll again go to the Processor menu and click Classify. And this time from the Set Specifications window, I'm going to uncheck Training Resubstitution, check Image Selection, and I'll check Write Classification Results to Disk File. It's going to write it to an erdas.gis file. And then check Create Probability Results File. Then I can click OK and the analysis will run. And I'll be prompted to save these 2 resulting files, and I'll take the defaults and click OK both times. Click Save and Save. Now to see the results, I'll go to File, Open Image. I want to make sure that my files of type is set to thematic. And then I'm going to choose the .gis file and click Open. I'll take the defaults on the Set Thematic Display Specifications window, click OK. I see the 6 classes on the left in the table of contents, and then visually I can see how the training areas were used to break the image up into these 6 classes. I'll go to the File menu and choose Save Project As, and call this Lab6. Now to see the training areas superimposed on these results, I'll go to the Project menu and choose Add as Associated Image. Now it's added the training areas, but they're white and they're difficult to see. There's not enough contrast. So I'll go to the Processor menu to Statistics, and the Set Project Options window opens. And under Outline Selected Areas, instead of color white, I'll choose black and click OK. And now I can see the training areas a little bit better. I can also change the colors of these classes, so I could double click on the color patch for trees and give that a green color, set the color for wheat, give it a yellow color, etc., so that I get a more intuitive rendering of all the classes. So let's examine the text output. So I'll open up the text window, expand it a little bit so I can see the results. And under class distribution for selected area, I can see this number of samples. This is the number of pixels in each training class in the image. And then it also gives you the percentage. So you can see that soil had the largest percentage, 43.72 in this case, and weeds was the smallest class at only 0.25% of the pixels. So multispec is a great tool for doing this kind of supervised classification, but if we want to use this data in QGIS Desktop, we can do that as well. So I'm going to bring up QGIS Desktop. I've got the original image in QGIS Desktop, and I'm just going to go to the Add Raster button, and I'll find the same .gis file and click Open. I'm going to have to go into the project properties for this image and the General tab and tell QGIS what the coordinate reference system is. It's in this UTM Zone 16 WGS84. This is in my recently used coordinate reference systems with an EPSG code of 32616. I'll click OK and OK, and now we see the image lining up in coordinate space where it should be with the other image. So I can style this similarly as it was shown in multispec. I'll double click on the image to open up layer properties, go to the Style tab, and instead of the default single band gray renderer, I'll choose single band pseudo color. I'm going to use random colors as the color ramp. Under mode, I'm going to change this to equal interval. I want to change it to 6 classes to match the number of classes that we had in our image. Then I'll click classify. And you'll see the 6 classes get delineated, and I can click apply. And this is nice, but we can also go in here and change the colors. Class 1 is going to be the trees, so I can click OK, click apply, and under the label I can change this to trees. Click apply, and we can do this for the remaining 6 areas. Okay, so I've gone through and given more intuitive colors to each class and given them good labels, and I'll click OK, and we see now a nice legend that we could use, so we can make a nice map out of this now in QGIS Desktop of our analysis results. So in this lab, you've learned the basics of working with multispectral imagery in QGIS Desktop. Then you also learned how to do a supervised classification using the tool Multispec, a freeware multispectral image data analysis system. So Multispec is a great example of many of the free-to-use programs available for imagery analysis and GIS-related tasks.